Hello, this is No Static, and we are going to solve a compound interest problem of the type needed in the Financial Mathematics Actuarial exam. First, the problem. Randy's fund is invested at an effective annual interest rate of 3%. Leahy's fund is invested at an effective annual interest rate of 2.5%. At the end of 20 years, the sum total of the two funds is $10,000. At the end of 31 years, the amount in Randy's fund is twice the amount in Leahy's. Calculate the total in the two funds at the end of 10 years. Okay, so the first thing we're going to do is set some variables for this problem. Namely, I'm going to let R stand for the Randy's initial deposit. And we know it grows 3% per year. Now, secondly, I will let L, of course, then stand for Leahy's initial deposit. And it grows at 2.5% per year. Now, we are given two pieces of information which will yield two equations for us. The first is that after 20 years, there's $10,000 total in the two funds. So that implies the following equation. $10,000 is equal to Randy's initial deposit times 20 years of growth, which is 1.03 to the 20th power. And also, we have to take into account Leahy's money. Leahy's initial deposit grows for 20 years as well, but only at 2.5%. So Leahy's initial deposit gets multiplied by 1.025 to the 20th power. Now, the second sentence is telling us that after 31 years, Randy has twice as much as Leahy, gives us the following equation. The amount that Randy has after 31 years, which is R times 1.03 to the 31st power, is equal to twice what Leahy has. Leahy would have 1.025 raised to the 31st power times his initial amount. Okay, so we have two equations and two unknowns, so there should be no problem here in finding an answer. What we're going to do is take that second equation and isolate the variable R, Randy's initial deposit. Then we'll plug it back into the first equation. So isolating R, that second equation, if we move the 1.03 to the 31st to the other side of the equation, and of course using a calculator to figure out what 1.03 to the 31st and 1.025 to the 31st is, gives us R is equal to 2 times approximately 2.15 divided by 2.5 times L. Now the 2.15 is approximately 1.025 to the 31st, and the 2.5 is approximately 1.03 to the 31st. Then when we simplify that, our calculator tells us that R is approximately equal to 1.72 L. So Randy started with 1.72 times the amount that Leahy started with for the initial investment. Okay, now we substitute back to the first equation. Instead of having that R in the first equation, we'll replace it with 1.72 L. So that gives us 10,000 equals 1.72 L. That stands for the R. And let's go ahead and figure out what the 1.03 to the 20th is. A calculator tells us that 1.03 to the 20th is approximately 1.806. The L we keep because we substituted for R, and 1.025 to the 20th is approximately 1.638. Okay, so we have one variable now. We can figure out how many total L's we have on the right-hand side 1.806 times 1.72 is approximately 3.106. And then we add to that 1.638 L's. And the sum total of L's on the right-hand side is about 4.744. And now we just divide that into 10,000 to find out what Leahy's initial deposit is. And we see that Leahy's initial deposit is $2,107.93. And then, of course, we multiply that by 1.72 to find Randy's initial deposit, which is then $3,625.63. Okay, so we found Leahy and Randy's initial deposit. Perhaps we've forgotten what we're looking for in this problem. If we go back in the problem, we see it says calculate the total in the two funds at the end of 10 years. So we have to figure out what's the total in the two funds at the end of 10 years by using compound interest again. That will be, let's see, in 10 years, we get 10 years of growth from the initial amounts for both of them. So that's going to be Randy's $3,625 times 63 cents will be multiplied by 1.03 to the 10th. And Leahy's original $2,107.93 will be multiplied by 1.025 to the 10th as well. When we figure this out, Randy has $4,872.54. And Leahy has $2,698.33. So the sum total in both accounts is $7,570.87. All right, there's our answer. Thanks for watching.